So if you want to connect your SAP, the SAP systems, the SAP data warehouse, simply mention SAP connected to Power BI. The very first website or the very first link will navigate you to the Microsoft Learn, which will give you insights. How do we connect SAP? What all options are there? See, you have to read it thoroughly, then only you will get a basic idea. I mean, prerequisites is you need to download this SAP.NET Connector 3.0 or 3.1. So you have an option, you have a link from here as well. You can, even if you navigate to this specific link, you can easily download it. You can easily download this. So you have to thoroughly read it. The information is clearly mentioned. Now, this is not only with respect to SAP, this is with respect to any specific data source which you want to connect. It might be SAP or it might be any other data source which you want to connect. You are not aware that how do we connect that specific data source to Power BI. Mention that specific data source connected to Power BI. It will give you all the insights. Now, in specific to SAP also, you can mention SAP HANA. You want SAP HANA connected to Power BI. So you have that option as well. SAP HANA databases. I mean, you want to connect that specific database. You will get all these options enabled here. I mean, enabled in the sense you will give the insights. You have to thoroughly read it, which connector is required, how do we connect, what steps we need to follow. So all that information is clearly mentioned. So you have this Learn document. I mean, in this Learn document, you have all these options, connector references, and all the connectors which are available, all that connector additional insights are kept. You see how many connectors, how many sources options are available here. Now you want to connect your Salesforce also, even Salesforce object, Salesforce reports are also there. So all these options, even Snowflake is there. So yep, Learn documents are there. You have to read it. Connection is easy, but very first time if you're doing it, yeah, you will face some difficulty. Once you have a good idea, then it's straightforward. I mean, you can easily connect it. Right now, I hope it would answer. Yesterday, few of you had a question related to SAP. Now let's continue with the BI analyst discussions. Probably I'll start with SQL. What do you mean by SQL? Because our first aim would be getting started with SQL, and then we would be jumping to the Power BI. Now, what do you mean by SQL? Why SQL is important? Now, let's start with an interesting discussion. Why SQL is important? See, whatever I'm trying to explain, whatever I'm trying to convey, I mean, maybe I'm trying to convey it in English. It is easily understandable for you people. It is easily understandable for you people. Now, let's assume there is a database. Now, what do you mean by database? Database is nothing but where all the information is stored. So wherever there is data, there needs to be a database. Wherever there is a data, there needs to be a database. Now, this is the database. Or probably this is a table inside a database. You can say this is database, and there is a table inside this specific database. So if I want to interact with this table, if I want to interact with this specific table, I need to interact using certain language. I need to interact using certain language. The same way I'm doing it with you. I'm trying to explain it in English. It is easily conveyable to every person because almost everyone knows English. There are few exceptions. Okay, they might don't know English, but the common way to interact with this within this IT field is English. So if I'm trying to convey any information to you, I try to convey it in English so that it is easily understandable. Now that same concept also goes with database. Database is nothing but where all the data is stored. And in that database, there are multiple other things in which you can store the data. Table is one of the things. You can store data in one of the table. Now, table looks like this. This is our table structure. And this is your database. So a database can have multiple tables, but in order to interact with the tables, in order to interact with the database objects, table is one of the object inside this database. So in order to interact with the objects present in the database, you need to have a language. You need to have a language which will help you to communicate with the database. That specific language is called a structured query language, which is your SQL. Now, this is nothing but a programming language because we are trying to program something, right? We are trying to program something. This is a programming language. How SQL is important? In order to communicate with the objects present in the database, or rather in order to communicate with the database, we need to use a language which is called as structured query language. That is the simple and straightforward definition of SQL. Now I'll take a pause. Any questions on this? We will discuss more insights on this, but just to get started with, I've given you an idea. What do you mean by database? Wherever there is data, it needs to be stored somewhere. Now, somewhere means it has to be database. Now, there are many other entities also. There is a data warehouse, there is data mart, there are data lakes. We will discuss all these storage systems in detail, but to get started with, database is very basic object. If you want to store any specific data, wherever there is data, if you want to store any specific data, it has to be stored inside database. And inside this database, there are multiple objects. Table is one of the object where the information is stored in table format. And you want to interact with that database, there should be a common communication medium, which is a database language, which is nothing but a structured query language. So it's a programming language to interact with the database. Any questions on this? Now, what would be the agenda for today? Why do we need database? What exactly database we have seen, but why do we need a database? How the database works, what the structure of the database is, what all schemas are present in the database, what specific schemas are present in the database, types of databases. There can be different types of databases as well. Why and what is SQL? I mean, we have seen how to interact with the database, the reason to use SQL, but there are different, I mean, in terms of SQL also, there are different ways of processing the information. How do you process that information? So more a kind of background insights related to database and the programming language SQL, we would be seeing insights. This is our agenda. Now, to get started with, as I've given an idea, what do you mean by database? See, if you can read this, no one, I mean, only information which you can get here, whatever information is kept, probably this is the only information which you can easily read it or understand. It is nothing but your SQL. The language is not easily understandable, or probably it is not our way or not our language. If that same language is written in this way, SQL or maybe English, SQL is most interactive way to communicate with any specific database. This is easily understandable. Why? Because we can understand English. Same goes with Hindi. Probably everyone or most of you would be able to understand this Hindi language as well, because we can understand English, we can understand this Devanagari script, not the Japanese script. So same goes with the SQL. SQL is nothing but the database has certain rules and regulations which it can understand. Now with that rules and regulations, SQL is the only language which is easily understandable by any specific database. Except SQL, there are many other languages also. Like if you want to communicate using Hadoop, if you want to communicate using Hive. See, these are all top-up languages. These are not pure straightforward languages. These are all top-up languages. But SQL is a very straightforward language which will help you to communicate with the database, and database would easily understand. So that's the reason people are using SQL. And SQL was introduced somewhere around 1960s. So how many years you can say? 40, 50, 60, almost 60 years, 60 plus years. Since last 60 plus years, this is still used. SQL is still used. Keep one thing in mind. Wherever you are, in whichever field you are, I mean, I'm not saying with respect to data field, in whichever field you are, SQL will remain throughout your career. If you know SQL, that means you know almost complete database. Since last 60 years, this is the only programming language which is still being used extensively. So keep one thing in mind, if you're good in SQL, you can survive in any specific field, because database is must in any role, irrespective of whatever role you are. Database, you should have an understanding of database. That means if you want to communicate with the database, SQL is must. So you should learn SQL. I'm not saying you should be very pro in SQL, but yeah, if you have a good insights, your knowledge, your basic insights are very clear with respect to SQL, then it is very easy to survive in this IT field. So going further, SQL is nothing but the only programming language which is easily understandable by the database. So why do we need SQL? Why do we need that specific SQL? We have seen how can we interact with it. Now, in terms of database, we have seen one entity, right? In terms of database, there are multiple objects. Table is one of the object. Now, if you look at the table looks like this. What do you mean by this structure? This structure is called as a structured information. The information is clearly structured. The information is stored in the row format. The information is stored in the column format. Now, if the information is clearly stored in the structured format, it is very easy to understand the specific information. It's very easy, because if the information is stored in row and column, it is, probably easy to understand, easy to fetch any specific information as well. So that's the reason structured information is very, very important. Now, what do you mean by structured information? How it works? See, if you take an example of dictionary. Now, dictionary is one of the book. If you take an example of library as well, even library, the information is in the structured format, because all the books are kept in one single, probably separate racks, but similar books are kept in one single rack. So the dictionary as well as the library, both the information are in the structured format. And if you want to fetch any information from a dictionary, or you want to get any specific book from a library, it is very easy to guess. It is very easy to grasp as well, because the information is in the structured format. So that is the importance of structured format. Now, why do we need structured format? Database itself is a structured format information. Wherever there is a database, the information is always stored in the structured format. That structured format is called as a table. Table is nothing but an object, but yes, that structured format is called as a database table. Example, dictionary, it is very easy to fetch information. So same goes with database. If the data is very high and you want to store that information in the database, so in that case, you should create a complete structured format, which is nothing but a stable object, right? That's how the structured information goes. So wherever, if you see this Wikipedia page as well, if you mention any specific Wikipedia page, you want to search something in Wikipedia also, towards left of the Wikipedia, you see all this information is in the index format. So if you want to learn anything, you want to directly jump to specific topic, you can directly jump. Why? Because the information is in the structured format. So importance of structured format, easy to grasp any information. If you're looking out for only certain point of information, you can directly jump to that certain point rather than reading it from start. So that's how the structured information plays an important role. Now, as I've said, database is structured format. So how do the database store information? How do the database store information? So data is nothing but a new fuel. Wherever you go, data is there. So wherever there is a data, there has to be a database. So in order to organize the data, we need to make a database. Most of the world's data is unorganized. Most of the data is unorganized. Most of the times the data is not organized. It is almost unorganized. But if you want to store that data in an organized format, that has to be in a specific database. So a database can handle large or huge number of records. Yes. Now the question comes, if a database is able to handle large or huge number of records, why do we use big data? Why do we use big data? See, big data is developed on top of database only. If a database can handle 10 GB of data, a big data can handle around 1 TB of data also. Now the question is, a database cannot handle 1 TB of data very precisely because the information in database is frequently updated. Now going further, you will get more insights. But if you still have a question that why do we use big data? Why can't we use database all the time? There are limitations with respect to database also. Yes, it can handle large number of records, but there are certain limitations. In order to overcome that limitation, the concept of big data came into picture. Now, why that big data came into picture? How is it useful? Going further, you will get some insights. But to clear your idea, if you still have a question, you might have a question that if a database can store large number of records, why not we use database? Why can't we avoid using big data? Big data is very, very high. Yes, database is high, but it is limited. Now, one of the most important aspect of database is web interface to data. Now, what do you mean by web interface? You can interact with the database using your website or probably using a cloud connection. Website is nothing but your cloud connection. So you can interact with the database from anywhere you are in the world. It is very easy to find information because the information is stored in the table format, which is rows and columns. It is very easy to fetch. Now, one of the important feature of the database is whenever, if you want to store data, you need a database. And inside the database, there is a table. But if you're storing a data and that data is nowhere useful going further, you want to delete that data, there should be an option to delete that data. Or else, if a data is stored and that data is not correctly stored, I want to update that information. So there should be an option to edit that information inside a table. So the important properties of a database is you can add, you can delete, and you can modify. That is, you can edit the information as and when required inside a specific table of a database. So these are the important features which makes database more flexible to use. It is structured. You can add information, you can edit information, and as well as you can delete the information from a table inside a database. So these are the important aspects. Now you can easily share and collaborate the data using database. Share and collaborate, it is nothing but your cloud system. You have created a database, but you want to share that database with multiple users. That database needs to be shared using cloud connection. Anyone who are part of different place, who are from a different place, who are part of a different country, but they are part of your same team. They want to interact with your database. They can easily connect using web interface, which is nothing but your cloud. So sharing and collaborating with the database is also very, very easy. Now, whenever there is a change of data, that change needs to be updated. Now that change needs to be updated means the reason to use database and the reason to use big data is slightly different. This line, the last line, will give you insights. Data changes very frequently. So make that change up to date. We need to save or manage it somewhere. That management area is called as database. See, in case of big data, the information is not frequently changing. It will remain stable for certain duration of time. Whereas in case of database, the information will change very frequently. That's the basic difference between a normal database and a big data. Now, in order to get some additional insights, let's wait for 5 or 10 more minutes. I'll give you a few more insights. The reason to use database, we have seen some important points. These are the few important points which will make database more flexible, more reliable to use. Now, going further, an example, how that information is stored in the database. We have seen a table format. So a table format is where the information is stored. Table is nothing but one of the object present inside a database. So sometimes a table is called as an object. Do not get confused. Object is nothing but a component present in a database. So every information is stored in a smaller entities, which is broken into smaller entities inside a table. Now that smaller entities are called as rows or columns. Sometimes rows are called as records. Sometimes columns are called as fields. So do not get confused. What do you mean by records and fields? That are nothing but rows and columns. Now, what do you mean by row? Anything which starts from left to right is called as row. Anything which starts from top to bottom is called as column. This is column, this is row. Horizontal and vertical information, rows and columns. A record, also called as row, is an individual entry that exists in a table. So for example, there are 10 records. That means there are 10 rows. 1, 2, 3, 4, up till 10 rows are present. And a column is a vertical entity. Row is a horizontal entity. Column is a vertical entity. Now, the question is, there is a slight difference. Now, what that difference is? Assume that this is a table, this is row, and this is column. So a row can be one complete set. It can be name, it can be ID. If you see for a row, this is one row or one record. Name can be some name, maybe my name, Ritesh. And ID can be one. Whereas in case of column, the data type of a column is always similar. Why? Because it is vertically stored. So name is one column, ID is one column. A row can have multiple data types. Why? Because row is stored in a horizontal manner. A row can have name, ID, surname, address, pin code. Every information has different data type. Whereas column is a vertical entity. So one column will have only one specific data type. If you change a column, it would be a different data type. So that's how the information is stored in a table format. You need to know very basic insights about row and column. Column cannot change data type. Yeah, you can change the data type using some language, using some query. But if a data type is assigned to a column, that information should be stored with that same data type. Whereas for a row, it can have multiple data types. And the information is always read in a row format. Yes, you can read it in a column format as well, but there is a limitation. So what do you mean by row? What do you mean by column? And additional insights have given you an idea. A table is broken into smaller entities, which will store information in different entities like rows and column. That is how the information is stored in the database. And table is the only format which is widely used. Now going further, this is how the table should look like. I mean, it's very easy. You can get this information anywhere. This is how a table will look like. One row and multiple columns. Now there are multiple rows also. These are all the vertical rows, horizontal rows and vertical columns. Now if you see instructor ID, this is one single data type. First time, this is one single data type. Now anyways, there are no numeric data types. So all the data types are string only. String information is stored in all the columns. But you can see a record will go through multiple columns. A record or a row will go to multiple columns, or a field will have only one single common data type. So this is how the table structure looks. It's very easy, straightforward to understand. Now, there is an important concept called as schema. Why and what do you mean by schema? Prior creating any database, you should first understand that how that structure of a database should look alike. Now, if you're taking an information, now database means wherever there is a data, there needs to be a database. Why do we need a schema inside that database? Let's take an example of house. You want to construct a house. So if you're constructing a house, you need to first finalize the design of that house, how that house should look like, what number of rooms should have, what are the dimensions of that specific rooms, might be living room, might be drawing room, might be kitchen, might be bathroom. So how that construction should look alike. You will first design that. Now, once you design that, you will first I mean, that design is implemented, you will do some structure of it. I mean, some structural audit you will do some basement of it. Now, somewhere without structure, design, without basement, you cannot construct any specific house. Similarly, a database is nothing but where all the data is stored. Without schema, you cannot create any specific database. Schema is nothing but your structure. Schema is nothing but your plan. How do you store information inside that database? Now, there are two different schemas. See, if you see, schema is the skeleton of the database. It is the background of the database, how the database should look like, where that information in the database should be stored. Basically, there are two different schemas. One is physical schema, one is logical schema. What do you mean by physical schema? And what do you mean by logical schema? Physical schema is nothing but your structure, your design. If you are taking an example of house, which part, which room should be constructed where, what are the dimensions of that room, that is nothing but your physical schema. And the other one is your logical schema. Once the design is ready, you are implementing that design. You are implementing that base and design. That base is called as logical schema. Base will always contain tables, views, and other constraints. Now, views, other constraints we will discuss in detail. These are also objects present inside a database. Table is one of the object, view is also one of the object. CT is also one of the object. Temp tables are also one of the object. The other constraints are also objects. So there are multiple objects present inside a table, inside a specific database. Table is one of the most commonly used object. Now, prior creating any database, you need to first define whether what physical schema and what logical schema it has to be. So schema is nothing but a skeleton. Physical is nothing but the design of that. And logical is nothing but how you are implementing that design. Physical schema and logical schema. These questions are generally asked in interviews. If you are a fresher or if you have 1 year of experience, you want to enter this field of data, you will be definitely asked what do you mean by schema and what are the two schemas, physical schema and logical schema. So you should explain in detail that schema is nothing but a skeleton structure and there are two different schemas, physical and logical. You can take an example of this construction. So I'll take a pause. Any questions up till here?
Ritesh, what do you mean by data stored will be stored in a secondary storage? What is a secondary storage here?
Now, secondary storage is a database can have multiple tables in it, or probably above database, there is one component called as server. This is table, this is database, and above database, there is a server. A server can have multiple databases. So one server can have multiple database, one database can have multiple tables. So secondary storage is nothing but if you are creating some structure, you're defining some structure, I mean, how that structure should look alike. It can be stored in a different table. It can be stored in a different database in a single server also. That is called a secondary storage. It is not every time that whatever structure you're defining for a single table, it should be common. It can be used for secondary storages also. So that's how the secondary storage is. It's straightforward. I mean, not that confusing. A server can have multiple databases. So whenever you are defining a structure of that database, a different database can also use that structure. That is called a secondary storage.
Okay.
Any other questions?
So can different databases have different structure? Can you do
Yep.
that?
Yes.
Oh.
It can have, you can define how a database should look like, how a table should look like.
Okay.
Okay, if there are no questions, let's go ahead. Now, Interaction with database, we have seen. What do you mean by SQL? How is it important? See, these are the features of SQL. Structured query language, fastest and easy way to interact with the database related aspects. Communication to the database, okay. We have seen all this. This is one of the important feature of SQL. You can execute, you can retrieve, you can insert, you can update, you can delete. All these options are enabled inside SQL. SQL is nothing but interaction medium, right? Interactive language. In order to communicate with the database, you can do all these options using SQL. Now, SQL became, these are all standardization concepts. SQL was introduced in 1960s or 1970s. Probably it was 1960 only, but in 1970 it came into highlight when the two IBM computer scientists. It was developed by IBM team, Donald B. Chamberlain and Raymond F. Boyce. So these people have introduced this language called as SQL. SQL is this concept, SEQUEL. This is the ideal name of the SQL. So they have dropped the vowels E-U-E. They have dropped this E, U and E. Only they have kept SQL. If you pronounce this and if you pronounce this, both are same. So that's the reason they have dropped that EUE and they have only mentioned SQL, SQL. So this was introduced around 1960, 1970s by IBM computer scientists. So two computer scientists have invented this. This is the exact history of SQL. Now, if you go ahead, it was standardized in 1986. Now, what do you mean by standardized? 1986 or 1987, there are two organizations which standardize this language. Standardized means they have made sure that this language is a standard language to interact with the database. This language has all the features. That's the reason it's a standardized language. Now, standardized language means, let's assume you are trying to purchase a product. Now, for the Indian public, it is specific to Indian public. If you're trying to purchase any product, you will see there is a mark called as ISI mark. What do you mean by ISI mark? It is a standardized product, a government registered standardized product. You have a AG mark. For any food product, you have a AG mark. If you see this AG mark, that means it's a standardized product. Similarly, for any programming language, usually ANSI and ISO. These are the only two boards which standardize that language. Even though the SQL was introduced in 1970s, 1960s, but this was standardized in 1986 by ANSI and 1987 by ISO. That means since then, this is the most preferred and standardized language to communicate with the database. Now, just to give you a brief about SQL, there are multiple languages. Hadoop is big data language. This is Spark. Even Spark is a big data language. Python. Python is one of the most efficient language. If you compare Python with Java, if you compare Python with C, if you compare Python with .NET, Python is most efficient language. Even Python is used to communicate with the database. But if you compare it with SQL, 60% of the crowd uses SQL. Rather than Python, also 60% of the world uses SQL. That's how powerful SQL is. And this is with respect to data languages. I'm not talking with normal programming language. It is with respect to data. You want to interact with data. Using Python also you can interact. Using R language also you can interact. Hadoop, which is a big data language. Spark, which is also a big data language. You can interact with that Hadoop and Spark as well. But still, if you see the market share of Hadoop and Spark, big data is boom now. If you learn big data, that means you have a very good exposure. But even then, SQL is most widely or commonly used database interactive language. So that's how important SQL is. So just to give you an idea, I've kept this graph, the real world usage of SQL. And anyways, we have seen the history of SQL. What do you mean by SQL when it was introduced? And why is it called as SQL? the vowels are dropped, EUE. Now, going further, this information will give you brief insights about why to use database and why to use big data. I've been saying that you'll get more insights about big data, why to use big data and why to use database. These two concepts will give you probably the basic difference between use of database and use of big data. So these are two different ways of processing any specific data inside a database. Even big data is nothing but your database only, but it is very large in size. It is very large in size. So there are two different ways of processing the information. One is OLTP, one is OLAP. Now, what do you mean by OLTP and what do you mean by OLAP? If you see, OLAP is nothing but your big data. OLTP is nothing but your normal database. MySQL, PL/SQL, T-SQL, PostgreSQL. These are all your normal database languages. Whereas OLAP, online analytical processing, deals with the big data aspects, which is nothing but your data warehousing aspects. Now, what do you mean by warehouse, lakehouse? I'll definitely explain you, but just to get started with, first understand what do you mean by OLTP and OLAP. Then maybe I'll give you high insights about data lake, data warehouse, data mart, and database. Now, OLTP always deals with the SQL languages. Now, why it only deals with the SQL languages? Why not big data? So let's take an example. You're going to a DMart, or maybe you're visiting any specific superstore, and they have a rack here, and in this rack there are certain food items which are kept. Now there are 4 food items, and if you purchase or if you take this one food item, you have taken this food item, you are at the billing counter, right? You are at the billing counter, and the billing monitor, this product barcode is scanned. Some barcode is scanned, so some 10 rupees amount is available, and you have billed it. A bill is available. This is your bill. Now, whenever this product is billed, that means that product should be removed from this database. There are only 3 products now. You cannot say you have 4 products. There are only 3 products now. That's how the information should be updated. If the billing is done, but still that product, that option is still available, that there are 4 products, there is a lag of information. That is not correct. If a product is moved out from a DMart or maybe any superstore, that product should not be present in the database again. The number should be reduced. If there are 4 products, if a person has purchased, that number should be reduced. This product should not be available in the database. So frequently updating information is nothing but your online transactional processing. There is a transaction done, right? There is a transaction of a product which is purchased. That transaction should be immediately updated that there were 4 products. Now there are only 3 products. One of the product has been processed or purchased. So that immediate change of information should be present. That immediate change is called as OLTP, online transactional processing. Now I'll take a pause. Any question on this OLTP? We will discuss more insights, but just to give you an idea, what do you mean by OLTP? It is an immediate effect or immediate change is called as online transactional processing. Any questions? Okay, silence, I'm taking it as no. If there are no questions, what do you mean by OLTP? This is OLTP. This is a very common example, but I've given it in a different manner. The banking system. If a person is trying to transfer a balance who has 10,000 to a person with 5,000 balance. So if that balance transfer is done after a successful transaction, if the balance of the person A needs to be updated, right? That needs to be updated immediately. That transaction needs to be updated immediately. So this 10,000, he has transferred around 5K. So 5K should be available in person B, which is 5 plus 5, 10,000 here. And this person balance should be updated as 5,000. If that updation is not done on that specific time or at that specific time, that there is a lag in that system, you shouldn't have that lag. So information which is getting updated frequently, the transaction information is called as online transactional processing. All our databases, all our SQL databases are called as OLTP databases because the information is getting updated at that specific time. You insert a record, it will be inserted at that specific time. You delete a record, it will be deleted. It will be deleted from that specific database at that specific time only. So you update it, it will be updated at that specific time. So whatever you are doing inside a SQL database, it is getting transacted at that specific time immediately. That is called as OLTP. There are many other ways. OLTP, your ATM, you're withdrawing an amount, your balance should be reduced at that specific time. You're purchasing a ticket. So if there are 100 tickets, 50 tickets have been purchased, the other 50 should be available. Not all the 100 should be available again. Why? Because 50 have been already purchased. So the information should be updated frequently. Your online shopping. A vendor is selling a product. He has 10 products. So some 5 products have been ordered. Ideally, that 5 products should be reduced from that vendor's information. So it should only reflect only 5 products are available as of now. So information is getting frequently updated or immediately updated, not frequently. It is getting immediately updated is all the example of SQL databases or online transactional processing. Now, what do you mean by OLAP? Let's forget the Zomato notifications which you get. What do you mean by OLAP? In simple terms, what do you mean by OLAP? If you visit a website, let's take, anyways, Big Billion Day sales is going on. Flipkart, Amazon, Great Indian Sale is going on. So if you visit Amazon or if you visit Flipkart and you want to purchase a product, maybe you are looking out for a mobile. You are looking out for iPhone 16. You want to purchase that iPhone 16. You visit a website or maybe you visit their application, Flipkart application or Amazon application. You search for iPhone 16. You look out the features. You go through the features. You look for any reviews if any reviews are available. And then you add it to a cart. You're adding it to a cart, but you're not purchasing it. You're adding it to a cart and you're not purchasing it. Maybe you keep this item for one day. The very next day, Flipkart will send you a notification or Amazon will send you a notification that you have a product which is available in cart. Why don't you purchase it? They'll give you some recommendation that this product will have so-and-so offer, so-and-so card discount, so-and-so EMI offer. So depending on your previous history, previous means last day history, Flipkart and Amazon is recommending you to purchase a product using some recommendations, using some discounts. So that recommendation, that analysis of information is called as online analytical processing. How they are analyzing? They are going -1 day. They are checking your history, browsing history, what you have browsed on their application, whether you have browsed for iPhone 16, how much time you have browsed it, how you have seen reviews, you have added it to the cart. So all this information has been analyzed. They will analyze this information and depending on their analysis, they will give you some EMI offers, some card discounts. So that analysis is called as online analytical processing. And how they are analyzing? They are analyzing using history data. -1 day means your historical data. They are not doing it on the very first day. They will first analyze that data and they might give you recommendation the next day. So that is called as online analytical processing. And in case of OLAP, the information is always a history information. It is not a live data every time. It is always a historical information. Same goes with your Zomato and Swiggy. You want to, you have ordered 10 products or maybe 10 times you have ordered in last 1 week. In last 1 week, you have ordered 10 times. And since last 2 days, you are not ordering anything. Zomato and Swiggy will send you almost every notification after every 1 hour that you have ordered last in 1 week you have ordered 10 times. Since last 2 days you have not ordered, they will give you some discounts that you have so and so discount from so and so restaurant. So that's how the analysis is been done. Depending on your last 1 week history, they will analyze and they will recommend you some offers or suggestions. That process is called as online analytical processing. OLTP is straightforward. It is updated at that time, whereas OLAP is done using historical data. It is analyzing your historical data. Now I'll take a pause. Any question on OLAP? Okay, that means you have got everything. The basic difference: online transactional processing, online analytical processing. It is nothing but you're retrieving a data. OLAP is used for large volume of data. That's the reason OLAP always has big data systems. Wherever there is a large data, in that case, OLAP will always come into picture. So it is used by large volume of data. OLTP is used by large number of transactions. Wherever there are large number of transactions which are updated at that time is called as OLTP. So OLTP is nothing but your database. OLAP is nothing but your data warehouse, or you can call it as big data. You can call it as big data. Wherever there is a big data, it is a data warehouse related entity. Yeah, go ahead. Someone has a question.
Ritesh, so in this case, the example that you've given, so basically Amazon, if we take the example of Amazon, it would have both database and big
Warehouse.
data, right?
Yeah.
So
Yeah.
for transactional data, it would have a database, and to store any historical data, it would have a data warehouse. That would be
Yes.
the big data, is it?
Yep.
Okay.
Yep.
Okay, got it.
So every organization nowadays is using OLTP and OLAP. Only OLTP is not recommended. Okay, if you're looking at the ATM system, the ATM table, whenever you're withdrawing any amount, this ATM table should be updated at that time. But for last 5 years, what you have done, that has to be stored in a warehouse. For last 5 years of transactions, usually a bank will store last 5 years of transactions in their warehouse, which is nothing but your big data. So wherever there is a database, data warehouse will also come into picture for analyzing the historical information. So OLTP is nothing but your traditional database management system, which is nothing but your SQL. All the SQLs are OLTPs, and OLAP is nothing but your warehouse. Now, what do you mean by warehouse? I'll give you an idea. So there are, multiple entities are present or multiple options are present, but the most common options are, first one is your data lake. Then comes your data warehouse. Then comes your data mart. And at the last, it is your database. Now, what is the basic difference? Anyways, you have already know database is OLTP and data warehouse is OLAP. And in database, it is frequently updated. Data warehouse, it is your historical data. So database is very small because transaction data, you can keep a transaction data of last 1 week, 1 year, maximum of 2 years, 3 years, not more than that. Because last year, last to last year information is more kind of historical information. Why do you want to store it in database? Directly dump it to the data warehouse. So how the information flows is, let's take an example. Take an example of perfume. Yesterday, we have taken an example of perfume. You want to purchase a perfume. So how this perfume is manufactured? This perfume is manufactured somewhere in the factory, or probably somewhere where all the raw materials are kept. So for perfume, there are multiple raw materials which are mixed together. So wherever there are raw materials which are mixed together, that area is called as data lake. That area is called as data lake because in data lake, all the materials are in raw format. Almost all the materials are in unstructured format. You can say all the components are in the unstructured format. So once you mix that, a product is manufactured. So that product goes to certain levels of information, right? When a perfume is manufactured, it is packed and it is shipped to the warehouse where, or probably a godown where all the perfumes are kept. So warehouse is nothing but a finished product, but it is not completely finished. All the products are assembled together in the warehouse or in a godown. So a warehouse, if you take an example of perfume, perfume can be of A, perfume can be of B. There are multiple perfumes, right? A flavor, B flavor, C flavor. There can be multiple different smells, right? So depending on what kind of perfume, that perfumes are arranged in different racks. Rack A, rack B, rack C, rack D. So depending on that flavors, the perfumes are arranged. So where they are arranged inside a warehouse, arrangement of data or partition of their data using similar set is called as data mart. Data mart is always present inside a warehouse only. Data lake is where all the materials are mixed together. Warehouse is nothing but all your materials are kept in a storage area. Inside that storage area, similar products are kept in different racks. That racks are called as data mart. And once that product has to be purchased, it has to come to the database because database is where it is nothing but a shop. Database is nothing but a shop or a finished product which is available to be purchased by a consumer. So if you're taking an example of perfume, where all the raw materials are mixed together it is called as a data lake. From that data lake, it goes to data warehouse where all the perfumes are kept in separate racks using some similar flavors. That similar flavors is called as, or separate racks are called as data mart. Data mart is always a part of data warehouse, and at the last, database will come into picture. Database is nothing but a single perfume. So if a person is purchasing a perfume, that perfume should be reduced from the database count. So that's how the flow of information is. Data lake is always greater than data warehouse. Data warehouse is always greater than data mart, and data mart is always greater than database. And keep one thing in mind, data mart is always a part of data warehouse only. Data mart is nothing but a similar set of products kept together in one single area. I'll take a pause. Any questions on this? Okay. Now, structured, unstructured. Data lake is always unstructured. It can be structured, but it is always unstructured. Data warehouse, sometimes it is structured, sometimes it is unstructured. So it is a combination. Not every time it is structured, not every time it is unstructured. Whereas most of the time, data lake is unstructured. Most of the time. You can dump structured information also, but why do you dump structured information inside a data lake? You can dump it to database. Most of the time, data lake is unstructured. Data warehouse is structured as well as unstructured, and database is only structured. It is only structured. Yep. Any other questions on this?
With this data mart, we can also say now it's structured.
It is structured. You can say it is structured, but it is a part and parcel of data warehouse. So you can also say that sometimes it can be unstructured also. But anyways, it is a part of data warehouse. In that case, if the information is kept in separate racks using some similar condition, it has to be structured.
Okay.
See, the definitions in the database are sometimes confusing. So do not get confused. As I've said, data lake is almost 99% of the time unstructured, but there is a chance that 1% of the time it can be structured. Whereas in case of database, it has to be structured. There is no option for us unstructured. Database has to be structured. The other three entities, it can vary. But most of the times data lake is unstructured, data warehouse is 50-50. Sometimes structured, sometimes unstructured. And anyways, data mart, it has to be structured, but it is a part and parcel of warehouse. So you can say it can be unstructured as well.
Hi, I have a question.
Yep, go ahead.
Then how we assess that unstructured data for analysis?
See, if you're going back to the data warehouse, assuming that it is structured or unstructured, you should always go back. Assess from data warehouse to database. If you want to dump any data, we use that ETL. We use the ETL services. So that is where we clean the data. That is where we massage the data and then we dump it to a database.
Okay.
Same goes with data lake. From data lake, you want to dump it to database. Yes, there is a possibility. You can avoid between data warehouse and you can directly take from data lake to database. But as I've said, you need to clean the data and then you have to dump it to a database.
So basically, we use ETL process to create transform the unstructured data to a structured data and save it into a data warehouse.
No,
Okay.
yeah, from data lake to data warehouse, from data warehouse to database, or from data lake to database also you can directly.
But in organizations, normally I think it is done by data engineers, isn't it?
Yeah, most of the times it goes with the data engineers. But I mean, in today's world, if you're creating any reports, not every time you can be dependent on a data engineer. And if the data is very high, you can go back and check with the data engineer. But if the data is dumped into warehouse and you want to take that warehouse data in a structured format, it is the role of a BI engineer or analyst to go back, get the data from a warehouse or lakehouse, clean that data and dump it to a table, which is used for reporting. I'm not saying completely done by engineers. Engineers will always work on frequent data loads. But if you're only working on certain set of data which is used by reporting purpose, you as a BI analyst or a BI engineer, you should go back and get that data.
Then what are the ETL tools we should know?
Okay, now I'm not sure if you have joined yesterday. We would be covering only one ETL tool here, which is nothing but ADF. There are multiple ETL tools. Informatica is one of the ETL tool. Talent is one of the ETL tool. Alteryx is one of the ETL tool. SSIS is one of your ETL tool. We would be learning ADF, Azure Data Factory, which is part and parcel of Azure Cloud.
Okay, get it. Thank you so much.
Hi, Ritesh.
Just a moment.
Hello.
Yeah, Manish, go ahead.
Yeah. Database means SQL, right? And
Database means not SQL. SQL is nothing but a medium to communicate with the database.
Okay. So OLTP used for transaction only. And database, data warehouse gives suggestion for history, give last history. So in data base, you use SQL, and for a data warehouse, what you
can use SQL. We can use SQL there also.
Okay.
We can use SQL there. We can use Hadoop there. We can use Hive there. There are multiple other languages which can. If the data is very big, it is always recommended to go with big data languages like Hadoop, Hive, Spark, R. You can use that languages, but yes, still you can use.
Like a code operation, like update is updation, delete, and code operation.
We can go with SQL. We can go with SQL. SQL, it is still recommended. But if the data is very high, in that case, you have to use Hadoop, Hive, Spark, Scala. These are all the big data languages.
Okay, but database like only used for transaction, and in data warehouse, it gives suggestion for previous history. for like means and what like I am asking about database use SQL or data warehouse, what you can use.
That is what I'm trying to say. See, if you have one database which will store 1 year of information, maybe you are in 2023, you are in 2023 now, not 2024, assuming. If this 2023 information has been stored inside a database and 2023 is done, we are in 2024. So this is 2024 new table inside a database. So this table would be dumped to a data warehouse. Data warehouse will always have previous historical information for 22 or so. So this 23 information would be dumped here. So when you were in 2023, you were able to fetch this information using SQL, right?
Yes.
Now you are in 2024, you can also fetch this information using SQL. But when this 2023 information in 24 has been dumped to a warehouse, this is your warehouse. This is your warehouse. If you are able to search using SQL in 23, why can't you search? If that information is dumped to a warehouse, why can't you search using SQL? You can still search it. But as I've said, it will take some time to get information if you're using SQL from a big data or a warehouse. It will take some time. Whereas if you use Spark, Spark would be faster from data warehouse. But SQL is nothing but it is one of the commonly or widely used language for any specific database transactions. You can use it in Lake also, you can use it in warehouse also, you can use it in database also. So we would be only learning SQL. At the end, we would be learning some Spark concepts when we move to Databricks in the Azure.
Hello, sir. I am asking one question also, like a warehouse
See,
suggest.
I got your question.
Yeah,
Maybe I'm trying to answer your question also. The answer is SQL is the only language which we would be learning for data warehouse also.
I got this.
Hmm.
I'm asking like a warehouse use suggestion for using SEO, search engine optimization. Yes or no?
Can you please repeat your question?
Warehouse using use some suggestion for his customer or whatever company. So warehouse use SEO, search engine optimization.
Search engine optimization is not present in SQL, it is present in Spark.
Okay, sir. Okay, sir. Thank you.
Any other questions? Okay, so I had a question from Mihir that is Python required for data analysis? Some amount of Python is required, not all the Python. So if you want to learn Python, you can skip this data analysis. Probably you can go with data engineering. It is not compulsory. If you know, it's an added advantage. Now I have a question from Amol that taking data from data warehouse to database, does it will make permanent changes in the database? Anything which you do in database, it would be updated at that time. It is not temporary. You again want to change it, you have to update it again. So OLTP is nothing but it's a frequent change, and that change is fixed. Fixed means that you cannot change. No, there is not that case. You can still change it, but at that particular interval, it is changed. That's it. So if you're taking unstructured data from data warehouse or data lake to a database, it will be a structured data only. Any other questions? Now, let me go ahead. In SQL also, there are two different entities. There is a SQL and there is a NoSQL. There is SQL and there is NoSQL. Now the question comes, what do you mean by NoSQL? Sometimes NoSQL, it can behave like big data or kind of unstructured data. Kind of unstructured data. These are all big kind of NoSQL databases. MongoDB, Cassandra, Amazon DynamoDB, In case of Azure, the Amazon DynamoDB, it's a part of AWS cloud. In case of Azure, we have Cosmos DB. I am not sure if you have heard this name, but wherever you will see this Cosmos DB, it's a cloud-based NoSQL database. Cosmos DB. MongoDB, it is publicly available. You can download and you can install this MongoDB easily. It is free source, open source. Now, what is the difference between SQL and NoSQL is, see, in case of NoSQL, the information is unstructured. That means it looks like a big data. It is not big data, but it looks like a big data. NoSQL is somewhere between SQL and big data. It behaves sometimes like SQL. It behaves sometimes like big data. Sometimes means 50% like this, 50% like that. It all depends what is the exact use case. Sometimes 60-40, sometimes 40-60 also. So do not get confused between NoSQL and big data. Big data is different. NoSQL is also different. NoSQL doesn't mean it is a warehouse. It doesn't mean it is a warehouse. It is only a database only, but it's a combination of SQL as well as big data components clubbed together. And there are many limitations. Data is not structured. It does not support joins and complex queries. Denormalized data structure. Now, what do you mean by normalized? What do you mean by denormalized? Normalization means information is breakdown into smaller chunks of information for easy processing. Whereas in case of NoSQL, all this information is kept in one single entity only. There are no smaller parts. It is very difficult to fetch information from NoSQL. Now the question is why people are using NoSQL. NoSQL is cheaper. It is cheaper than SQL. So sometimes if any organization feels that we want to use a combination of SQL and big data and we want it a bit cheaper, then you can go with NoSQL. Limited use case. Do not get confused between NoSQL and big data. NoSQL is in between SQL and big data. It is between OLTP and OLAP. There are many limitations. It doesn't follow ACID properties. ACID properties means atomicity, consistency, isolation, durability. We will see some example with this probably tomorrow. But just to give you an idea, joins, subqueries, CTs, many other things are not supported in NoSQL. There are many limitations. But the only thing is it is cheaper than SQL. Sometimes it behaves like SQL. That's the reason people are using NoSQL. So do not get confused between SQL and NoSQL. NoSQL is in between OLTP and OLAP, in between SQL and big data. Now I'll take a pause. Any other questions? Now let me complete. We have started with SQL today only. We have seen some insights yesterday. Why do we need, what is the role of the data engineer or maybe role of a data analyst, BI engineer rather, what all tools are required. So this course would cover, give me an idea, give me a moment. Right, so we would be starting with SQL. One who have joined only today, we would be starting with SQL, which will have minimum of 22 sessions. So you can assume that complete October would be covered inside this SQL because we have sessions from Monday to Friday, not on weekends. Monday to Friday and morning 8 to 9:30 a.m.
So SQL, which one? MySQL or SQL Server?
Now the question is, what we would be learning is MySQL. Once you go to the Azure, there you will get the SQL Server. SQL Server is a paid version. It's a paid version. You need to have a cloud. You need to connect to the SQL Server. It's a paid version. We would be learning with MySQL. I would be covering almost all the aspects which are present in SQL Server as well. So you shouldn't have a question that if I'm giving you MySQL information, it is not similar like SQL Server. No, I would be covering the SQL Server entities as well. Now, once the SQL is done, we would be going to Power BI. Power BI would be somewhere around 40 sessions, minimum of 40 sessions. It can be plus minus 2 or 3. So it would be 2 months, November and December. And in the month of January, we would be starting with Azure. So 4 months, 3.5 to 4 months is the complete duration. 25 sessions. And inside this Azure, as I've said, ADF would be 70% and 30% would be other services which are used from a data analyst point of perspective. Because ADF is much important. It is the most widely used ETL tool nowadays with respect to Power BI, because both are product of Microsoft. Azure, it's a part and parcel of Microsoft Cloud, and Power BI is a product of Microsoft. So that's how we would progress. 30K for this course, just to justify, we are giving you premium per user license for Power BI, which is 2K per month. So 2K plus 2K, you will get 60 days of license, which is 4K. So it is rather 26K plus 4K. That's how it goes. Now, if you want to pay in installments, in 3 installments, it is 10 plus 10 plus 10. In 2 installments, it is 14 plus 14. And in 1 installment, it is 27. So you can always reach out to the KSR team for any payment related entities. How do you reach out? If you simply go here, this is our website. From this website, you can come down, you can contact on this number, or you can email. Our team will definitely reach out to you. There are other numbers also. There are other numbers as well here. You can contact these numbers as well. For any payment related, how do you make a payment? Yeah, you can always go back. Today is the second session. You still have 3 more sessions. I would request you to wait until last session. If you feel my teaching is good, easily understandable, you are able to understand, then you can go ahead and proceed with the further paid sessions.
Yeah. What about Microsoft Fabric session?
Okay. Now Fabric is inclusive of Power BI. In Power BI or inclusive of Azure. It would be combined together in Azure and Power BI. We would be learning in that only. In Power BI service, we would be starting with basics of the Fabric. In terms of ADF, ADF is also available. The data factory is also available in Fabric. So that we would be discussing in Azure sessions.
Okay. So in ADF, we create a bronze layer, silver layer, and gold layer also?
No layers are available. We are not connecting it to GitHub. Layer is only in the organizations. What do you mean by layer? Layer is nothing but development environment, test environment, and production environment.
Yeah.
What you do in development that can be easily navigated to the production. Only layer is nothing but the hierarchy of information.
Okay.
You would be covering all the activities and pipelines or how that activity works. So you will get a brief idea how ADF is used.
Ritesh, I have a Pro version installed on my system. So can I still use that for the course, or I need the premium user? Power BI.
See, Power BI installation is not Power BI desktop is anyways free. If you want to publish a report and you want to share that report, you need to have powerbi.com in Pro.
Yeah, so I'm able to open the workspace. I am able to access the app.powerbi.com. and I'm able to see my workspace there. So is that enough for the course?
See, we would be giving you the KSR email IDs. Have you been part of KSR previously?
No.
Okay. Now we would be giving the email IDs with KSR domain. So you can utilize that email IDs. You will get premium per user, not pro, premium per user.
No, but
That
if I
would be
have
shared.
Pro, is that still enough, or do I need the premium per user?
Pro is different. Pro is different. See, licenses is only for sharing the reports. Power BI desktop is free. If you want to share and publish and share that report, Pro is also okay. But why you want to go with Pro if you are giving you premium? Pro is
No, I already have it on my system. So I was asking, can I still use that because I have it on my system already?
you can still
Or should I still pay for the PPU because we need it for the course? Like that's
Now
what
the
I was
question
saying.
is, if you are having a Pro and you have with a different email ID, right?
Yes.
No, you cannot interact that. You will not get the Fabric license also. In case of Pro, Fabric license is also not available.
Okay, so for this, if I have to like do this course, then I need the PPU for sure, is it?
PPU for sure. Minimum of PPU.
Okay, got it.
Any other questions? So it's anyways, second day only. You will get some insights going further. We would be starting with programming probably tomorrow. Then you will get some insights how the SQL progresses. As I've said, I would be starting with ABC. Somewhere after 1 week, the pace will increase gradually. So that's how we would start with Power BI also, and that's how we would start with Azure as well. So you will get an idea about SQL. If you are good to understand by Friday, then you can take your call. And again, I'm open for questions. If you have any other questions, feel free to ask.
Ritesh, I have one more. So can you like tell the difference, like you said, MySQL and SQL Server, right? What is the difference? And also, so SQL, you're saying it's a language. And also in your last slide, you said SQL is a system and then NoSQL is also a system. So, I mean, what is the difference? Can you give me?
SQL Server, that is what you're expecting?
Yeah, so what is that and what is this and what is, so SQL, you said it's a language. Again, SQL, you're saying it's a system. So
No. The question is, in SQL, MySQL is nothing but a system here.
okay.
MySQL is system, and you want to interact with this MySQL, you need to use a SQL. SQL Server is a system, and you want to interact with the SQL Server. SQL is the language here. Now, MySQL is developed by Apache platform. It is developed by Apache platform. It is open source. It is open source. It can be installed as on-prem, and it can be on cloud as well. And Apache is a product of Oracle now. Oracle has purchased this Apache. So it was developed by Apache organization. Now SQL Server, it's a separate, you can say it's a separate component, but in order to interact with SQL Server, you should also know SQL only. But SQL Server is a product of
Microsoft
Azure Cloud. Yeah, it's a product of Microsoft, which is nothing but the Azure Cloud. So it is owned by Microsoft. SQL Server is always a cloud-based system. On-prem, yes, you can still use it, but it is a bit difficult here. Almost all the time it's cloud-based. It is not open source. It is a paid entity. Depending on what kind of database you're using, what kind of database units you're using, it's a paid entity. Same goes with Oracle. Oracle is a system. In order to interact with this Oracle, you need to use a SQL. Oracle is called as PL SQL, procedural SQL. SQL Server is called as the T-SQL, Transact SQL. There are very slight differences between MySQL, T-SQL, and PL SQL. MySQL, I mean, you can say it's one of the oldest. T-SQL and PL SQL have some, maybe you can say, latest updates. I'm not saying MySQL is outdated. Your Facebook is developed on top of MySQL. Facebook is completely developed on top of MySQL. Still, Facebook uses MySQL. Oracle is also a paid entity. It's a cloud-based paid entity. It's a product of Oracle. Even MySQL is a product of Oracle, and Oracle is also a product of Oracle. That's how it works. Apache was a different organization. It was purchased by Oracle. So if you want to, if you want a real-time example, real-time difference, let's talk about a language. Hindi. You're talking about Hindi language. Hindi in North India is different. Probably in certain state, it is different. Maybe UP, Bihar, Madhya Pradesh, it is different. Hindi spoken in Maharashtra is different. Hindi spoken in southern states, it is different. But anyways, every language is a Hindi language only. There are slight differences. That's how SQL works. SQL is same, but if you're interacting with MySQL, it is slightly different. If you're interacting with SQL Server, it is slightly different. And if you're interacting with Oracle, it is slightly different. There is PostgreSQL as well. If you're interacting with PostgreSQL, slightly different. Anyways, SQL is common. But depending on where you are using, on which system you're using, there are slight changes. That's how the language works.
Okay. So if we are learning all the Microsoft products, right, then aren't we going to use the T-SQL or the SQL that goes with the SQL Server more? Or does it like impact or?
If you're using MySQL, yeah, can you please repeat again? Yeah.
No, so we are using like Fabric or, Power BI or anything with Microsoft, right? So you think learning MySQL would still help?
Okay, now
If
question
we have
is very
SQL
good.
Server in the company.
Question is very good. Now, if you go with SQL Server for 1 month, minimum you should have 5 or 6,000. You should pay minimum 5 or 6,000.
Sorry, I didn't get you.
If you want to use SQL Server and the amount of practice which we would be doing, minimum of 5 or 6,000 should be required. So if you're using the SQL Server for 1 month, 5,000 charges. If you want to continue using the SQL Server going ahead, again 5 more thousand. See, the question is, what we would be doing would be a high level information. I would explain how it can be done in SQL Server as well. Once we go to Azure, you will get the Azure, with that KSR email ID, domain email ID, which would be shared to you. Once you activate the Azure portal also, in that case, you can activate your SQL Server where you will get 20,000 Indian credits, 20,000 rupees or 16,000 Indian rupees. You can still activate, you can practice it at that time. But anyways, as I've said, language is same. What I would be explaining it in MySQL, that can be similarly done in SQL Server.
Okay.
There is a very slight change. That slight change I will explain at the maybe at that specific time, whichever I am discussing. Maybe we are discussing views. How to write a view in MySQL, how to write a view in SQL Server. I'll explain that.
Okay. The objects would be same between MySQL and SQL Server.
Yes.
Okay. So SQL Server, would you say it is a database? What is the term?
It's a database.
It's a database.
Cloud-based database.
Okay. Sorry, what did you say? The last thing?
The cloud-based database.
Cloud-based database. And MySQL is on-prem database.
MySQL is both. Even you can use it as cloud-based as well. But we would be using on-prem.
Got it.
Any other questions? Any other questions?
Ritesh, I have one question. In case, right, if I opt in for the Azure and Fabric, right? Just now you mentioned, right, this subscription I mentioned, right? You provided the subscription as well, right? In case if I'm opting for the only
you would be given email IDs there as well.
Okay, got it. Thank you. That's it. Yeah. Yeah.
Email IDs are shared irrespective of whatever course. Only SQL is not there. SQL and Power BI is there, or Power BI and Azure is there, or only Azure is there.
Got
So
it.
anyways, you will get the email IDs.
Well, it is not online, right? It is not internet is not required. So when it comes to SQL Server, it's in a cloud, so internet required. So like the storage, because if you are storing in cloud, so data will like heavy, right?
See, if you're storing it in your on-prem, it would be stored in your local system. Now, if you want to store it in cloud, it is heavy. In that case, the charges would be heavy. That's the reason many people, if you visit any specific institute also, if they say they're trying to, teach you in MySQL Server, they'll not give you the SQL Server access. They'll ask you to pay the SQL Server. It's a separate entity. I can share the SQL Server from my end. Now the question, let me give you a highlight. It's a good example. In the very almost 2 years back, when I have taken a batch here, I have at the last of SQL sessions for 2 days, I've created a database in the cloud. I've created a database in the cloud, and a database can have, I've created a server. Rather than database, you can say I've created a server inside a cloud, which is your SQL Server. A server can have multiple databases, right? A server can have multiple databases. This is one database. It can have multiple databases like this, and every database can have multiple tables present in it. Now, when I have created a server, I've shared this server publicly. Publicly in the sense, the one who had access, one who were part of that batch. So if you're taking an example of MySQL, you can create n number of databases inside this MySQL server. Server is at the topmost level. Below server, there are databases. You can create n number of databases in MySQL and you will not be charged. Anyways, it's a free. But when I have created a SQL server and I have shared, people were so used to that they have created 10 databases. One person has created 10 databases. What I have said is try to create tables rather than creating databases inside one database. I have created a server. I have given one database inside that server, but that person instinctively created multiple databases because he wasn't aware. Why? What wasn't he aware? That it's a paid service. For one database, if you create, it will cost you 1K even if you use, even if you don't use. So 10K it costed. Now the question is whether he was able to pay. No, we haven't asked him. It's our fault. The reason why we are not learning or not giving you this MySQL or SQL Server, rather. SQL Server is a paid entity. If you create a server and by chance, if you forget, you create one database per day, it will cost you 1K even if you use, even if you don't use it. So you should know how that SQL Server works. What is the minimum configuration you can set so that 1K is not, maybe you're not getting billed for 1K per day or maybe per month. If you use it for 1 month also, it will be 1K only. If you don't use it for one month, or maybe you are creating for 1 day also, it will still cost you 1K because the configuration has been created with 1K billing. So that's the reason people avoid using SQL Server. Many a times videos are available in SQL Server, but the access is not given for a SQL Server. If you're working for an organization, yes, it is given. Any other questions? Okay, if there are no questions, it's almost 9:30. Silence, I'll take it as no. Yep, we would be connecting back tomorrow with the MySQL discussions, how to install and how to connect that. Thank you, everyone. Have a very good day. Yeah, let's meet tomorrow.